Okay, so now we're going to use all the things we've learned about quadrilaterals and specifically parallelograms to find different angles and side lengths in shapes. We'll use this later on in more complicated ways, but let's just start with the basics. Okay, so let's start by looking at this example. And if the instructions here, which I didn't have room to type out, are find the measurements of all missing angles, all unknown sides and angles. So if I look at this I know this is a parallelogram because opposite sides are parallel. So first off, in parallelograms, opposite sides are congruent. So this side is 8 and this side is 15. Okay. Now, I want to look at the angles. These sides are parallel. These are alternate interior angles, so they are supplementary. So this is 127 degrees. And then you can either think, oh, I know opposite angles are congruent, or these are also same side interior angles, which makes this 53 degrees, and this is also 127 degrees. Okay, so that's sort of how we think about that. We think about what kind of shape it is, and then we think about the properties that we know that would help us do it. So why don't you pause and go through these remaining three pictures and try them on your own. Okay, so now that you've tried these on your own, if I look at this next shape here is a rectangle. Okay, and a rectangle, opposite sides are congruent. All the angles are 90 degrees, right? So if that angle is 39, this is 59. Alternate interior angles here, we have this, right? And then in a rectangle, we know that the diagonals are congruent and they bisect each other. So we have all of these angles are base angles of isosceles triangles is one way to think about it, right? Okay, or alternate interior angles, lines are parallel. And then all these little sections of the diagonals are 18. If the length of the diagonal is 16, if I asked you that. Okay, on to the next shape. This is a rhombus. Okay, this one, the sides are pretty easy because they're all congruent. Right? Opposite angles are congruent to each other. And again, because this is a parallelogram, these are parallel. So these angles are same side interior, so they're supplementary. Okay. The last shape on the screen is also a rhombus. Okay. This one has a little bit extra. So we know these are all 10. We know this has to be 6 because it's a diagonals bisect each other. In a rhombus, diagonals are perpendicular, which makes these all right triangles. And if you do the Pythagorean theorem, or if you know the Pythagorean triple, these are 8. Okay. Now for the angles. This angle here, right, we know that to be 53. And the reason we know that's 53 degrees is because of the triangle sum theorem in this triangle, right? In this right triangle. Okay, this is also 37 degrees. This is also 53 degrees. Okay, we also know that all 4 of these triangles are congruent. So this has to be 37, 53, 37 degrees. Okay? Okay, here's one last example for you to try. So push pause and go for it. Okay, now that you've tried this, so there's a lot of things to do here. Let's start with finding the easy stuff. This is 7, okay? This is an isosceles trapezoid, so this is also 73 degrees, right? Which makes this one, right, 107 because you know that these lines are parallel, right? And these have to be supplementary. So similarly, this is 107 degrees, okay? Okay, so now if we look down here, we want to figure out this length, right? And that's the hard one. Well, if we drop another altitude down, right, these two triangles have got to be congruent, okay? And the reason is that these altitudes have to be equal. So now we have HL, right? So by HL, those two triangles are congruent. So what that means is that this length here is 2. This shape here is a rectangle. So this has to be 8. So if you add all that up, that is equal to 12. And so that's everything we want. If we wanted to find out the height of this, right? If we wanted to know the height, we could do the Pythagorean theorem. It's not going to work out nicely, but 2 squared, we'll say the height, equals 7 squared. So 4 plus 8 squared is 49. So that is 45. So h is the square root of 45. And just a little reminder, if you wanted, this should turn into 3 root 5, right? If you remember, if you don't remember how to do that, remind yourself how to simplify radicals, but hopefully you remember. So 3 root 5. So there you go. So that's how you find all the measurements, angles, and sides in special quadrilaterals.